Kotlin's property delegation allows us to customize the behavior of a property, and today we're going to use it to make it incredibly easy to use Android's shared preferences as a backing for properties. Shared Preferences is a simple interface from the Android API that allows you to persist primitive key value pairs. So stuff like strings, numbers, booleans, just give them a name and store them on the device for later. Out of the box, Kotlin's standard library lets you use a map as a delegate. In order to learn more about property delegates, we're going to do the same thing for shared preferences. After we do that, we'll circle back around and improve the code for better type safety and to make it a little more configurable. So let's get started. You might have used property delegation for observable properties like UI state in Jetpack Compose, as we're doing here on line 16. You know you're using property delegation whenever you see the word by on a variable or a property. Code that uses property delegation is kind of just saying, I'm not going to store the value myself. I'm going to hand it off to some other object to store. So in other words, anytime that you were to read this variable here, it's going to get its value from that delegate. And anytime that you assign a value to that property, it's going to pass it along to that delegate to store it. If you've got a class and you want it to serve as a delegate, you just need to give it one or two operator functions. So first, you need an operator function called getValue. Whenever the property is read, like we're doing down here, it's going to call into this function, and whatever that function returns is what that will evaluate to. Second, if you want the class to serve as a delegate for both val and for var properties, like we've got here, then it also needs to have a corresponding setValue function. And as you can guess, this function will get called whenever you assign a value to that property. The parameters in these two functions are pretty simple. The first parameter is called thisRef. And this refers to the object that contains the property. So in this case, we've got this class that contains this property that is delegating to the simple delegate. And so this ref is going to be an instance of this class here. In other words, it's the object that said, I'm not going to store this value myself. Most of the time I leave this as any, so that this class can be a delegate in any class. If you want it to also work in a function, you could use any with a question mark here instead. Just know that the delegating type has to be the same as or a subtype of the type of this ref, or it won't compile. So let's put this back to any so that it will continue to compile for us. The second parameter is called property. And this refers to the actual property itself right here. KProperty comes from the reflection package in the standard library. And finally, in setValue, there's a third parameter. It's called value, and as you can guess, that's just the value that's being assigned. Now that we know how property delegation works, we can use it to wire up properties to shared preferences. We just saw how easy it is to create a property delegate in our own class, but how can we do the same for shared preferences? Since it's part of the Android API, we can't modify its code directly, but with extension functions, we can still augment it to do what we want. So to start things off, I've got two extension operator functions attached to shared preferences, one for getValue and one for setValue. We'll get this working with only Boolean properties first, and then later we'll come back for the other types that are supported by shared preferences. So as you probably know, to get a Boolean out of shared preferences, we can call getBoolean with a key. And to make this as simple as possible, we can just make the key the name of the property like this. Shared preferences also wants a default value as a second argument here, so we'll just go with false. To write something to shared preferences, we have to get its editor, so we'll call edit like this. And then inside, we can call putBoolean with a key and a value. So again, we'll use the name of the property here, and we'll just pass the value through. Okay, let's fire up our Android emulator, and here you can see a control that's backed by our settings repository, so it's using those shared preferences. We'll hit the switch here to enable turbo mode, and we'll hit the save button. And now, when we restart the app, we'll see that our preferences for turbo mode was saved. Now, shared preferences supports other primitive types besides just Booleans. If we want to support those as well, one option would be to change these to generic functions. That's quick to do, so let's explore that. Let's look at set value here first, and we'll add when value. And when the value is a Boolean, then we will do that, put Boolean. Okay, let's copy and paste this line for the other types that we want to support. The compiler doesn't require it, but we really should add an else branch here so that if we try to save a type that isn't supported, we'll get an exception. Now let's come back up to this getValue function. Here we can branch based on the type that needs to be returned. So notice that what we have here is a type, it's not an object. When we had an object in setValue, we were able to use is to check the types, but here we only have the type. So how can we branch based on this type? Well, we could try doing a when based on the class of the type argument using t::class. But when we try to do that, we'll get a compiler error, as you can see. And that's because we can only get the class from a type parameter that is reified. So to get that, we just need to make this an inline function, and we'll mark that type parameter as reified. And now Kotlin is happy with t::class, but we still need to add an else case, which will throw an exception. And we can fix that remaining error just by doing a cast at the end. With this, we can now save other types of properties like strings and numbers. So there you have it. With just 30 lines of code, we've made it really easy to use shared preferences as a delegate for a variety of primitive types. You can see how this is a very easy pattern to support not just shared preferences, but any kind of key value storage. So for example, we could use the same approach for things like a cache or maybe an on-device database. Just remember that this is what you would call a chatty interface. It calls through to your delegate for every read and every write. So you probably wouldn't want to use it to store the main data of your application. But for simple key value pairs, it can work well. There are some things I don't like about this approach though, so let's explore some ways that we can improve it. I love how easy it is to delegate to shared preferences here. It's simple, it's elegant, it's concise, but there are a few issues with this. For example, you have to use the property name as the key for the shared preference. Also, you have to accept these defaults that are just kind of hard-coded in here. And most importantly, it's not as type safe as I want it to be. The getValue and setValue functions here are generic, and as they're written, they'll accept really any type that you give them. Shared preferences, on the other hand, supports only a handful of types, including the ones that we've got here. So this mismatch creates a problem. The compiler is perfectly happy if we want to try to delegate properties for types that shared preferences doesn't support. For example, if we were to do an unsigned integer, there's no compiler error, or if we wanted to do even an Android context object, that's fine too. And in fact, we can even do a function type like that. And there's no compiler error telling us that this isn't going to work. All that happens is when this is running at runtime, we're going to get this unsupported operation exception. So how can we get the compiler to prevent us from just ever using those unsupported types to begin with? One idea would be to split up the functions so that there's a separate one for each of the supported types. So that's what I'm doing here with setValue. You see we've got a different one that supports Boolean, one for int, float, long, and string. And so they're split out and we're not using a generic here anymore. This does indeed work. It prevents us from delegating a var property to anything other than the supported types. I've only split out setValue though, so the problem still shows up if we were to set these properties to val. You'll see here, compiler's still happy with it. Unfortunately, we can't split out getValue the same way because the overloads conflict, as you can see here. Remember, function overloads are distinguished based on their parameter types, not based on their return types, and these functions only differ in their return types. It worked with the setValue functions because there's this third parameter, and that was a different type in each case. With no support for union types in Kotlin, I can't think of any way to keep this really nice, concise delegate expression and get the type safety that I'm looking for. So if you've got other ideas, let me know in the comments, but I'm pretty sure we've reached the end of the road for this approach. So instead, we can split this out in a different way. Instead of hanging the getValue and setValue functions directly onto the SharedPreferences type, we can create a separate object for them. In other words, we could create a function like preferences.boolean delegate. And that function would return an object that has getValue and setValue functions on it. And it would still have a reference to the SharedPreferences instance. Let's take a look at that. So here's what that function looks like. You can see I'm using an interface here called readWriteProperty, and that's got the getValue and setValue functions on it. You don't have to use that interface, but it's there if you want it. And instead of creating a new named class, I'm just creating an anonymous class this way. Also, fun fact, you don't have to put the operator keyword on these two functions when overriding them from the interface. As you can see, this object that's getting returned still has a reference to the SharedPreferences here. So when we're calling edit and we're calling getBoolean and putBoolean, those are referencing that SharedPreferences instance. Let's just quickly copy and paste this for a float delegate. So that's the exact same thing, just for a float instead of a Boolean. So only the types and the name of the function have changed here. And we can kind of see a pattern emerging here. But before we go too much farther, I'd like to look into the discoverability of this a little bit. With code completion features, we can see a couple of the delegates here. We've got the Boolean delegate and the float delegate here. And that's all right. You can type delegate and it'll shorten up that list. I'm kind of inclined to create a separate object that's just delegate. And so in other words, we could do like delegates.boolean like that. I think that'll be a little bit better developer experience. So to do that, I'll just wrap these functions in a new class. We'll call it SharedPreferences Delegates. And we'll pass in the SharedPreferences. And we'll change the receiver type here so that it doesn't need a receiver type anymore. Take those out. And we will also rename this to Boolean. And we'll rename this one to float. And then you can see it's not resolving where the SharedPreferences is, and that's because we passed it in here instead. So we'll do prefs like that. And same thing down here. And now let's create an extension property on SharedPreferences for that delegates object that will have all of the different types of delegates. And now we'll have all of these supported types under this object, and our code completion menu shows us exactly what we want to see. Now this is starting to feel a little heavy-handed. Like this is a lot of code here, it's a lot of code here, and if we're gonna have to do this for every type that SharedPreferences supports, it's gonna feel a little heavyweight. So what I'd like to do is I'd like to see if we can pull out a small abstraction. We'll just make a little factory function that can create this read-write property for us. As we're trying to pull out a good abstraction here, it's good to look for the things that vary. So we've got the Boolean object at the top, and we've got the float object at the bottom. And what we're doing is we're trying to find things that are different between the two of these. And so obviously the type is different there. Type's different here. What else is it that changes here? We've got the getter here and the put function here. Those are different. And then finally I see we've got a default here and a default here. And this exercise helps us to identify the parameters that we'll want to include in that new factory function. So let's call these out again here. We've got the default, we've got the getter, we've got the setter, and the type is going to just be part of a generic. So we'll make that T. Okay, so let's get in here and create a factory function. I'm just going to make this a private one. We'll make it a generic function. We'll just call it create. And we got a few arguments here, so I'm going to put these on separate lines. We'll start with the default, which is going to be of type T. We also identified that we'll have a getter, and it's going to take a string and a T and return a T. This is one thing you can do here is you can put little identifiers on these guys, and it's not actually used for anything other than making it clearer to the developer what's going on there. The setter is going to take a string and the value that you're going to set it to, and we're going to return the editor. From here, we'll just create the object. This will still work on any, but we'll make this second type argument a generic one here. Let's implement these guys. So first we'll make the getValue function, and this is going to just call that getter. We'll continue to use the property.name. We'll pass in the default, and we'll move on to setValue. This is just going to call the setter with the property name and the value. And then because this is an editor, we have to still call the .apply on that. And remember, that apply is not the Kotlin scope function called apply. This is actually a function that's on the SharedPreferences editor. With this, we can go back up to our other functions and update them to use this. So here we can just call create. We will pass in our default of false, and we'll use a function reference to send the getter and another one for the setter. Remember that it's going to have to come off of that editor, so we'll call edit first and then pass in the function reference from there. Okay, let's do the same thing for float. Now we're supporting custom defaults for each of these, but we aren't actually allowing the call site to pass them in. So we're still hard coding them here and here. But if we move these out to parameters for these two functions, then the call sites can specify whatever they want for the default. So let's come in here and we'll say default type of Boolean, and we're going to give it a default here of false. And we'll pass it in that way. Now the call site can pass it through, but we still have a default for our default. All right, and then we'll do the same thing here. Now we can specify custom defaults here, which is nice. So if we don't want to use false, we could use true and pass that in. That'll be our default there. Or if we want to use a different kind of float, that'll work as well. So now we just need to add this for integers, longs, strings, and string sets, and they'll all follow the same pattern. So as you can see, I've gone ahead and implemented the rest of these functions, and they all pretty much just follow the same pattern as we were using before. There is one surprise that'll get you here though, and if we switch back to the usage site, you can see we've got this error here on line 6, and the reason is this is returning a nullable string type. So if we change this to a nullable type, everything's good, but we don't want it to be nullable. So why is that happening? Well, this getString and getStringSet as well, they both can return a null whenever you give it a default of a null. We don't want to support a default of null. We don't want the nulls in here at all. So let's make a few changes to prevent that from happening. First thing, we don't want the default to ever be null. So let's come in here and set this to any. And now you can see we get a few errors up here. And these are going to be pretty easily solved by just creating our own lambda. So let's do that. This lambda just wraps the underlying function and casts the result. There we go, and that works. And we'll just pop in the same change for string set. Now, we know that in practice, we'll never have a null, and so it should be safe to do the cast that we're doing there. And finally, I would love to update this so that we don't have to use the name of the properties as the name of the key for shared preferences. To do that, let's add another parameter to all of these functions. We'll call it key, we'll make it a nullable string, and we'll default it to null. Down here in our factory function, let's add another parameter for the key. That's going to break everything above it, that's fine. We'll just pass in the key in each case. And finally, we'll just add a new function that will either use the key that was provided or pull it from the property name. And then down here in getValue and setValue, we'll just call that. And with that, we're now supporting custom keys. And the last thing I'm going to do is I'm going to go through and specify all of these types explicitly, just to make sure that there's not going to be any problems with type inference. So there we go. We're still under 50 lines of code. It's a little bit more than the 30 that we had with the first approach, but this one supports custom keys and custom defaults and has better type safety. So I think we're doing pretty good. We've tucked away the small amount of boilerplate that was required for shared preferences, and it's pretty easy at the call sites now. All right, and before we wrap up, let's launch this up in our emulator. And we can set our nickname to something. And we'll set our throttle somewhere over here. We'll leave the turbo mode on. We'll hit save and close out the app. And when we launch it again, everything's saved. All right. Looks like things are working like we expect. Well, there you go. With just a few dozen lines of code, we've managed to make it absurdly easy to read from and write to shared preferences with type safety, discoverability, and custom keys and defaults. If you'd like to see this example working in a full Android project, you can check out the description below where I link to a repository. Also, if you've got ideas on ways that we could improve this code, let me know in the comments. See you next time.